We are going to get to interaction effects. I promise you we will, but let's look a little more closely at significant main effects, and then we're going to look at the interaction effects. All right, so let's say that we are looking the F value that's going to look at the main effect of hemispheric dominance. And let's pretend that this F value is significant. Do we need a post hoc test? Well, let's look down here because these are the two means that would be compared if we're looking at the main effect of hemispheric dominance. So the F value is going to tell us whether or not these two means are different. Now, if that F value is significant, we now know the two means are different. Do we know where the difference is? There's two means that are different. Do we know where the difference is? Yes. There's only two means. What other means could be different, right? There's only two there, so obviously the difference has to be between these two means. So you would proceed by saying not just that they're different, but you will want to say which one is higher and which one is lower. So we would conclude that people in this study, people who are left hemispheric dominance, probably are more creative overall than people who are right hemispheric dominant. Now, I know that you've probably read sources that say that, oh, if you're right brain, you're more creative. And okay, well, we're not going to go there. All right, I'm just saying based on this hypothetical data set, we would conclude if we have a significant F value for the main effect of hemispheric dominance, we would conclude that people who are left hemispheric dominant are probably more creative than people who are right. Okay? Do not do a post hoc test on this data, on these marginal means, because you only have two. Okay? Post hoc tests are only done if you get a significant F value and you have three or more means you're comparing. So now I've given away the answer to this next question. All right. If main effect of marijuana is significant, do you need a post hoc test? And the answer, of course, is yes, because the F in the ANOVA to look at the main effect of marijuana is going to be comparing these three marginal means, right? So if this F value, the one for marijuana, is significant, it means you have a difference somewhere, but you don't know where. All right, and so with three or more means, you're going to need to follow up with some sort of post hoc test, and that post hoc test will compare the means 2 by 2 to see which means are different from which. Now, because this is set up as a two-way independent ANOVA, or we could call it a two-way between subjects ANOVA. Why? Because both factors are between subjects. So if this is a two-way independent ANOVA or a two-way between subjects ANOVA, then if the F value is significant, the types of post hoc tests you would probably run would be Tukey, Chaffee, and LSDT. Remember, which one should you look at and keep? Well, you look at all of them, and you keep the one you like the most, the one that gives you the results you were hoping for, assuming one of them gives you the results you were hoping for. It is important, though, that you tell people which post hoc test you ran. That's critical. Okay, they have to know. Now, let's say you get the same results, pattern of results from Tukey, Chaffee, and LSDT. Which one should you report using? Do you remember? Chaffee. Chaffee is going to make, it's going to look the most impressive, right? Because it sets a very high bar for significant results. And Chaffee also has the lowest risk of making a type 1 error. So if you get the same pattern of results with all 3 post hoc, use Scheffé. And then if you don't get the pattern you're looking for, then move to Tukey, because Tukey would be next on the list of being impressive. And it has the, second, it has a little bit more, a greater risk of a type 1 error than Scheffé, but it's second, right? So it's still pretty good. The last one you would want to resort to would be LSDT. All right, so those are the 2 main effects.